Hey guys, in this video I'm gonna talk about Wien's problem. So in Wien's problem, you are given an array P in which Pi tells you about the price of the ith wine. Now you have to sell these bottles in such a way such that you can maximize the profit. Now there are certain rules that you have to follow. The first rule is that you have to sell exactly one bottle in each year. And the second rule is that you can sell extreme left or extreme right bottle in any year. And the third rule is that prices of wine bottles increase each year. That is, in the yth year, price of ith bottle will be Pi times y. Now, how can we solve this problem? So the first approach that can come to our mind is greedy approach. So in greedy approach, what we can do is we can see that if I sell the cheaper bottle in this year, then the expensive one will have more increase in the next year. So if I sell the so in this problem I have two options in the first year, that is I can sell the bottle with price 2 or bottle with price 4. So I will sell the bottle with price 2, that is I will have a profit of 2 times 1. In the next year I have to choose between 3 and 4. So I will choose 3 here. So I will get 3 times 2 plus. Now I have options between 5 and 4. So I will choose 4. So 4 times 3. And now between 5 and 1 I will choose 1. Now at last I have to choose 5. Now if I add these, I can see that I have a total profit of 49 here. Now what if I choose some other ordering? Now what if I choose to sell 2 first? I will have 2 times 1. Now between 3 and 4 I choose 4. So I will have 4 times 2. And between 1 and 3 I choose 1. So I will have 1 times 3. And between 5 and 3 I choose 3. 3 times 4, and I choose 5 at last. So if I add these, now this will give me 25, this will give me 12, 12 plus 25 37, 37 plus 3 40, and 40 plus 8 48, plus 2 50. Now I can see that I have got a total profit of 50 here, which is greater than the 49. So there exists some other ordering which will give me better answer than the greedy approach. Now it tells me that I should try all options available here, and for that I have to apply dynamic programming. So the most important step in any DP problem is to decide the state of that problem. So let's guess the state. So at first, if we choose index as our state, what does it tell me? So I have an array, let's say p1 p2 p3 dot dot dot. Now if I am at this index, I don't know how many bottles I have sold from left of it and how many bottles I have sold from right of it. So it's not a good state. Now what if I choose L2R as my state? What does it tell me? So L2R tells me that I have sold all the bottles that are left of L and all the bottles that are right of R. So this is a pretty good state. Now there is something missing, which is that I don't know the current year, but from this state I can know the current year, which is that if I know how many bottles I have sold in total, then I know the current year. So if this is length and total bottles were, let's say, n, so how many bottles I have sold? I have sold n minus len bottles. So the current year will be n minus len plus 1. This will be my year. So this is the unique state for our dp. Now let's talk about the transition of our state. So I have to find dp of L to R. How can I find this? I have two options available here. If I sell the leftmost bottle or I sell the rightmost bottle. Now if I sell the leftmost bottle, what will I have? I will have, let's say I have found my ear. So I will have P of L times Y plus dp of L plus 1 R. And the second option is P of R times Y plus dp of L R minus 1. So these are my two options and I have to choose the maximum between them. So this is our recurrence relation. So in the greedy approach, what we were doing, that we were looking at the locally optimum solution, but in the dp approach we are looking at globally optimum solution, and it will give us the better answer. Now if I draw the tree for this dp problem, we can see certain things. For example, let's say we have an array of 4 size 0 1 2 3. Now we have to find answer for 0 to 3. We can choose between 0 and 3. If I choose 0, I will have 1 to 3. If I choose 3, I will have 0 to 2. Now if I choose between 1 and 3, okay, let's flip them, 0 to 2 and 1 to 3. Now if I choose between 0 and 2, if I choose 0, I will have 1 to 2. If I choose 2, I will have 0 to 1. And in the 1 to 3, if I choose 1, I will have 2 to 3. If I choose 3, I will have 1 to 2. Now we can see that we have overlapping subproblems here, and we also have optimal substructure, because if we find the answer for this and this state, let's say this is x, this is y, we have to choose maximum of x and y. So this is the top down approach for our dp problem. Now let's code for this problem. At first we are given n, the number of vines, and we are also given a p array. Let's define them globally, L, L, N and P of N. Let's make our N as this. Now I have to take input for the P array. So ref I 0 N. Now let's make a function. So it will give me the profit between L to R. So now let's clear the base case. Now if L is greater than R, we have to return 0, and else we have to do transition between our states. Now we have two options here, LLX equals to P of L times, what is the current here? Let's define our here as N minus R minus L plus 1 plus 1. So this is our current here, and we have to make recursive call, otherwise we have P of R times Y plus compute of L R minus 1, and we have to choose the maximum between them. So okay, let's take it Z. Now we have to choose between X and Z. So we will return maximum of x comma z. Now let's make our DP array. DP of, let's say, 100. So I have to memset my DP array, and after the base case, if DP of L to R is not equal to -1, DP will return DP of L to R, otherwise we return DP of L to R equals to max of x comma z. So this is our DP solution. Now let's find the answer for 0 to n, not n, n minus 1. Okay, so let's print our answer. Let's give it an input of 2, 3, 5 and 4. So we have 5 elements, 2, 3, 5, 1, 4. Let's see if there is any problem in my code. I don't think that there is any problem. Let's build it. So we are getting 50, which is correct. So this is the code for Wines problem. So that's it for this video, guys. If you like this video, give a thumbs up and subscribe to my channel for more videos. Thank you.